Really? Uh-oh.
15.
Okay, what's the result of integrating? We got x cubed over 3. Is that what you had? X cubed over 3 plus 2x.
15.
Okay, so we write integral, everybody?
Yep.
Okay, so we got 3 cubed over 3 plus 2 times 3. Okay, technically minus 0. Okay, 3 cubed is
27.
divided by 3. 9 plus 6 is 15. Now, if you look back in your notes, this is the exact same problem that we approximated with all the other methods. Okay, we did this exact same problem we approximated with Riemann sums, with Simpsons, with the trapezoidal. Okay, we got approximate answers. The exact area under the curve would be 15. Okay, so that's kind of the basic idea of it. It's integrating, you plug in the upper bound, it's the value of the function, plugging in the upper bound, minus the value of the function, plugging in the lower bound on the integrated function. Let's turn the page and keep going, because obviously we're going to get a little bit more involved with the integral part.
Plus 1.
Okay, I'll have you do 3 and 4, and then we'll talk about 5. 3 and 4.
Okay.
Number 3, what answer did we get?
Negative 15 halves.
Negative 15 over 2?
Yeah.
Okay, did anybody not get negative 15 over 2? Okay, and I want you to just, again, make this connection visually. Okay, we have a negative answer because, okay, the function is not above the x-axis. The function that we're talking about is below the x-axis. Okay, the function is below the x-axis. You will get, and you should get, a negative answer when the function is below. You're talking about area between the function and the x-axis. By the way, is it possible for a function to cross over the x-axis? Yeah, you could have a portion above and a portion below. You're going to have to add those results to get the total area. Okay? Oftentimes, if you're talking about symmetry, you'll get a value of 0. Think that through a little bit. Okay, number 4. Did we get an answer to number 4?
54.
4. That one's almost too easy. Did anybody not get 54? Maybe not?
No,
Never mind.
You sure? Got it?
Sure, I'm not that good.
Okay, now. All right, I just asked for the answer, and I would want the answer. Okay, but again, this is where notation is important. Okay, you do want to show the results of integrating, okay, your definite integral. And I definitely would want to see your upper and lower limit. Again, you can use a straight line or you can use a bracket. People like to often leave that off. Okay, but your total answer here is 54. Okay, let's take a look at number 5. Okay, we're got a definite interval from 0 to 1 of x squared over 1 plus x cubed quantity squared. So now we're going to have to work with the definite integral using the substitution. Or you can multiply, no, you can't multiply that bottom and simplify it. So what would you do first?
Find the derivative.
Okay, I think it's a very good habit to always move the basis to the numerator and work with a negative exponent. I think that's a good habit. So I'm going to rewrite this problem. I have a definite integral from 0 to 1 of x squared times the quantity 1 plus x cubed to the negative second. Okay, just move everything to the numerator. Okay, I'll have you go ahead and integrate on your own. See what you come up with. bring your whale back, Jake. You should get an overall answer of 1/6 of the decimal equivalent.
Can you go through it?
Yeah. Let's do it. 1/6. Okay, so let's what did you set u equal to?
1 plus
1 plus x to the third. Okay. What is du?
3x.
3x squared. Don't forget your dx. Okay. So again, you're looking for something that when you take the derivative of it, that is part of the original integral. Okay. So what does the integral whale eat up here? We got the x squared, the dx, that gets eaten up. Okay. You put a 3 in there, that's going to get eaten up, but that means we have to multiply by what on the outside? 1/3. Okay. Now, what we're integrating here, okay, you're working with 1/3 and you're integrating u to the -2nd, right? That's really what we're integrating. Okay, when you integrate u to the -2nd, I'm going to remember that 1/3 is there, it becomes what? Bump it up a power and divide by that power. So it becomes what? U to the -1 divided by -1, which really makes that a -1/3. Okay, so this is really -1/3, you've got u to the -1st. So we don't have a plus c anymore, this is a definite integral, but let's plug u back in. So now you've got -1/3, okay? Plug u back in, you got the quantity 1 plus x to the third. To the -1st, you can put that in the denominator if you want to. But now we're going to integrate this on what to what?
1 to 0.
0 to 1.
Either way.
Okay, if you want to put that quantity in the denominator, it is equivalent to -1/3 times 1 plus x to the third. Okay, those are equivalent. Okay, everybody okay with just our integration so far? Okay, a lot of people make a mistake and would bump that up to the wrong power. Be careful. Okay, so plug in our top number. So we would have -1/3 times, what's 1 plus 1 to the third power?
2.
2. Okay? Now, just because there's a 0 for the bottom limit, don't skip that step. Okay, you're plugging it in. So we're going to take that quantity and we're going to subtract the result of plugging in the lower limit. So we've got -1/3 times, what is 1 plus 0? 1. Okay, a lot of people will try and make that a 0. Be really careful. So we end up with -1/6 plus a positive 1/3. Okay, minus a negative is a positive. What's -1/6 plus positive 1/3?
1/6.
Okay, so be careful when you have zeros for the upper lower limit. Go through the process of plugging it always in. It won't necessarily always result in an overall 0. Okay, what do we think? Definite integral? Fun?
Yep.
Okay, here's what you need to do. You need to go back to assignment 8 now and add in the exact answers. So you should have 3 answers for each problem on assignment 8. JK. Okay. And we got some work in the book, and there's a worksheet here. You don't have a lot of room on this worksheet. Check the assignment. It's odds. If you want to work on a separate sheet of paper, that's fine. You've got some indefinite and also definite integrals. So indefinite, don't forget your plus c, but you already have that? Yeah, you do. I already gave it to you.
I think that was
A different one. Okay, with a definite integral, your answer is a constant.
Can I stop this now?
I think you can.